Okay, class, this is a review of what so many of you have asked questions about in class. These are 5 ways that you can factor on the test on Wednesday when we ask to factor. Here are 5 things that you should be going through in your mind to determine, okay, how am I going to factor this? So I'm going to give an overview right here. First of all, the 5 ways are: you can factor by asking questions. You can factor out a common term or terms. We would call this a common monomial because it's one term. Some special factoring patterns, AC factoring, and factoring by grouping. The first thing that we're going to look at is how to factor by asking questions. And when I say factor by questions, we mean the 2 questions: what multiplies to get your C term or the third term, and what adds to get the B term or the middle term. Here I've got a trinomial, x squared plus 7x plus 12. In order to factor by asking questions, the first thing I would look at is the leading coefficients, which would be this x right here. Because there's no number in front of this x squared, I would say my leading coefficient is 1. Therefore, we have x squared plus 7x plus 12. Our a term would be our x, or our 1 in front of the x. Our b term would be 7, and our c term would be 12. Okay, so now that we have that in our minds, we can ask ourselves, what multiplies to get 12 adds to get 7? Well, 6 times 2 gets 12, but that doesn't add to get 7. And 1 times 12 is 12, but it doesn't add to get 7. So that leaves us with 3 times 4 is 12. And it does add to get 7 because 3 plus 4 is 7. So here we have x plus 3 times x plus 4. And now these are the factors, or the factored answer of x squared plus 7x plus 12. Another example would be x squared minus 3x minus 18. You would ask yourself, what multiplies to get negative 18 and adds to get negative 3? So we could think of 9 times 2, but that doesn't add to get negative 3. 18 times 1 doesn't add to get 3. But negative 6 and positive 3 multiplies to get negative 18 and also adds to get negative 3. So we'd have x plus 3 as our first factor and x minus 6 as our second factor. So these are the questions that you ask: what multiplies to get your third term or your C term, and what adds to get your B term. The second thing you need to look at in factoring is to see if there are any common terms that you can factor out. In this case, we can look at our leading coefficient and we see that it's 4. Then we could say, alright, well, that may be a tough factoring problem, but let's look at the other terms. This is 8 and this is 12. These are all divisible by 4. So my common monomial in this case would be 4, because every term is divisible by 4. So if you divide 4x squared by 4, you're just left with x squared. And then if you divide 8 by 4, you get 2, and then an x. And then if you divide negative 12 by 4, you get 3. So this is your common monomial that you would factor out first. In the second example here, we have 12x to the 5th plus 15x to the 4th plus 3x cubed. Well, again, our leading coefficient is not 1, so it would be hard to factor by questions. So we can look to see if each one of these is divisible by the same number. And in this case, we know that they're all divisible by 3, and we know that they all share at least 3 x's, or x to the third. So we would say 3x to the third is our common monomial, and you divide each term by 3x to the third, giving you 4x squared plus 5x plus 1. The third way we can learn how to factor or factor a problem is to look at special factoring patterns. These would be when you have both an a term and a b term that's either a perfect cube or a perfect square. And in this case, The first pattern I want to remind you of is the difference of squares, which is when you have a number squared minus a number squared. Difference meaning subtract. It factors out into a plus b and a minus b. If you have sum of cubes, that means there's a plus sign in between. It factors out into those two cube roots, or a plus b, and then your a term squared minus ab plus your b term squared. And the difference of cubes follows a similar pattern, except it's a minus b as your first factor, and then there are plus signs in both the second factor. So that's something to be aware of, and those are your special factoring patterns. That leads us to an example. 4x squared minus 16. Well, if we have 4x squared, that's a perfect square because the square root of 4 is 2, and the square root of 16 is 4. So we know that is 2x plus 4 and 2x minus 4. May I remind you that the square root of x squared is x. That's why we have a 2x plus 4 and a 2x minus 4. In the second piece, you have 27x cubed minus 64. And from our work, we know that the cube root of 27 is 3, and the cube root of 64 is 4. So we know that we have an a term, which would be 3x, because cube root of x cubed is x, and our b term would be 4. So this is our a, this is our b. Now if we factor it out, we'll follow the pattern up here, and it will be 3x minus 4, and then square it, so that'd be 9x squared plus 12x plus 16. The fourth way we can factor is by AC factoring. Here's our example that has a leading coefficient of 2. So we know we can't factor immediately by questions, but we can multiply our first term by our last term. In this case, 2 times negative 12 is negative 24, and don't forget your x squared. So now we can actually factor by some questions what multiplies to get AC and adds to get B. In this case, negative 8x times 3x is negative 24x squared. So we have our middle two terms, and what we're actually doing is writing negative 5x as the sum of negative 8x and 3x. So we're going to rewrite our original problem, this time creating 4 terms. Now you take the first 2 terms and group them, and the second 2 terms and group them. After you've grouped them, you see what you can factor out of the first set of terms. In this case, both pieces are divisible by 2x, and in the second case, you can divide by 3. Your goal in this case is to get 2 sets of binomials in parentheses that are exactly alike. So in this case, I've got x minus 4 and x minus 4, so that becomes one of my terms, and my other term is 2x plus 3, which are my leading, or the terms that I factored out. The last way that you can factor is if you're given 4 terms, which I've already alluded to when you do AC factoring. But when you're factoring by grouping, you take the first 2 terms and the second 2 terms and put a set of parentheses around them. After that, you find out what factor or what number you can divide into both of your terms. In this first case, both terms have a factor of x squared that they share, leaving you with x plus 3 in parentheses. In your second set of terms, you have both pieces that are divisible by 10, leaving you with x plus 3 in parentheses. The parentheses need to be twins, and those are your first term of your factors, your first set of factors, excuse me. And your second set of factors, or your second binomial factor, is x squared plus 10. So my final answer would be x plus 3 and x squared plus 10. If the question says to continue to factor and solve, you would do exactly what we've just done. only you would continue to set each piece equal to 0. So x plus 3 equals 0. That would mean that x equals negative 3. Then I would set x squared plus 10 equal to 0. And then I'd move my 10 to the other side, which in order to solve, I would take the square root of both sides, and I'd find out that x equals plus or minus I on the square root of 10. I hope that you've enjoyed learning and reviewing the 5 ways to factor. If you have any other questions, please feel free to let me know, and I hope you do well on the test on Wednesday.